This is Paul Hennessee. I'm going to be showing off the graphing calculator that I made for my Computer Science 3A final. As you can see, this is the graphing terminal. And if you go over here, we can see all of the commands. So you can quit, clear graphs, enter graphs, swap colors, change the domain and range, zoom in and out. And as you can see, this is displayed the x and y axis. I'll enter in a couple functions, x and x squared. Now this will show that the numbers on the axis aren't exactly correct, but I put them there so that it's close enough to show the general location of where everything is. If you zoom in and out, it'll change where everything is. So there's three portions to this project as far as how it works. The first is the tokenizer, and what happens there is when you enter the function, it takes in a string from the user, and this gets tokenized into portions. So putting in, let's say, x times sine 1 over x. Now, everything that you enter needs to be separated by spaces because that's how I check for different tokens in the tokenizer. And it'll split up the string into different types of variables and numbers, operators, and that gets tokenized, and then it gets passed into a shunting yard. And now this algorithm takes the string and it reorganizes it so that it can be evaluated just by running through. So this is, it gets a postfix, and this is passed into a graph class. And what the graph class does is that takes it takes points and it plots a bunch of different points into this evaluated shunting yard, and then it plots them onto all of the range of points that's displayed on the screen. So it goes at intervals of 0.0001, so it's decently accurate. It's not amazing once you get closer, but it's accurate enough once you're further out. So if we zoom in all the way over here, you can see it's starting to get a little messy and not as accurate. That's because the interval is a little too short for us to be accurate on. But for out here, it's good enough. So you can put in functions, and you can use sine, cosine, and tangent. We didn't do arc cosine, arc tangent, and arc sine, because for those you have to limit the domain of the function, and we don't want to deal with that. So you can see sine of x divided by cosine of x should be tangent. Here, let's zoom out a little bit. Okay, and then if we swap colors to green, then if we enter in another function, then we should show, or if we enter in tangent, it should go exactly over. So we can see that tangent is indeed sine x over cosine x. So you can put a lot of other functions in here, and it's a pretty neat project, I think. So these are some of the functions that the professor had up on the board that he wanted us to do. So I'm just putting some of them into here just to show off that we can indeed do this. So yeah, that's pretty much it.